And here's the packet lesson. Section 2.2 starts on page 57. And we're just going to dive right in. So here we got a boat of some sort cruising along on the water, looking up at a helicopter. And let's read this problem. It says the angle of elevation from the boat to the hovering helicopter is 32.2. So right there is 32.2 degrees. And the helicopter is 600 meters above the water level. That's just telling you that's 600 meters. Again, we can assume that this is 90 from the pre-lesson. And it says, what is the horizontal distance? That's not this. That's the horizon distance. So they're asking you to find x. So here we go. Now we're ready to use trig. I'm going to write so, ka, toa. And we'll come back to that probably on all three of these problems. So if this is our reference angle, yes, we could figure out what this is, but we're not going to take the time to do that. We're going to concentrate on this and say, well, that needs to be my opposite side. And because this is my hypotenuse, I know this must be my adjacent side. And I'm going to use this side and this side to do my calculations. Well, what trig function uses opposite and adjacent? Tangent. That tells you take tangent of 32.2 degrees, and you're going to put the opposite over the adjacent. And now you take your calculator, turn that on, clear it out. Make sure you're in degrees. So again, we're going to go mode. Check down here, you can see degrees is highlighted, so we're good there. And I'm going to go tangent of 32.2, hit enter. I got 0.629, so I'm just going to say that's 0.63 equals 600 all over x. So once again, I'm going to multiply by x because that cancels. And I'm going to multiply this by x. So I get 0.63x equals 600. Divide by 0.63. Divide by 0.63. And I'm going to get x is 600 divided by 0.63. 952, we'll call it 0.4. 952.4. Now, before I just go on to the next problem, does it make sense that this side would be 952? In other words, bigger than this side? Yeah, because if this is 32.2, that would mean this would have to be 57.8, because these two need to add up to 90. And if this is a lot bigger than this, then this side should be a lot bigger than this side. So it just makes common sense. Next one. Now it says the angle of depression. Now if you were listening to my pre-lesson, which you should have, I said, you know what? That's the same thing as the angle of elevation. So we're just going to put it down here and just let the drawing be the drawing. And it says of a buoy from the top of a Barnegat Bay lighthouse, 130 feet above the surface of the water. So that's just telling you, let this side be 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base, that's here, of the lighthouse, to the buoy. So they're saying find x. Well, if this is my reference angle, that means this is my opposite and this is my adjacent. This is my hypotenuse, and I'm not going to deal with that. So opposite and adjacent, well, we just did the same thing, so we're going to have to use tangent again. But this time, its tangent of 6 degrees is 130 feet. I'll leave the units off, over x. So I got to take my calculator, find tangent of 6 degrees, 0.105. So 0.105 equals 130 all over x. And I'm going to multiply this by x so that those cancel. I'll just slide my x right in there. So I got 0.105x is 130. Divide by 0.105. And here we go. 130 divided by 0.105. 1,238, almost perfect. 1,238, and it is 0.09, but we're just going to call that good. And again, if this is 6 degrees and we know that this is our 90, that means this has to be 84, which means this side needs to be a lot bigger than this side, and it is. Common sense. This one's a little trickier, so gotta pay attention, be ready to adjust. So it says from the top of a 100-foot tall hall, so I know this is 100, a man observes a car. So there's a dude up here, and his eyeballs are right here. So observes a car. There's a car moving toward the building. So this car is moving this way. If the angle of elevation of the car changes from 22 to 46, so that means this little sliver, 22, and then as he gets closer or she gets closer, it's 46 degrees. During the period of observation, how far does the car travel? So if you think of this, we've got two different distances here. So what we're going to do is we're going to figure out what this is, and here's where my markers will help out. So I've got this triangle, and I'm going to go ahead and draw that over here. And that guy looks like this. Now it might be a little smaller than the actual, but you get the idea. So that's 22 degrees. This is 100. And I'm going to call this whole distance x. See, my goal is to figure out what this is. So as you watch, I'm going to first find x, which is right here. Then I'm going to figure out this blue chunk, and I'm going to subtract the blue chunk from x, that big long part of the yellow triangle, and that'll leave me with the pink chunk. So that's my target. This is just an excuse to get you to use trig functions twice and then do some subtraction. Here's my reference angle. This is my opposite side. This is once again my adjacent. Looks like it's just going to be a tangent party. So tangent of 22 degrees equals my opposite over my x. Now they won't always be tangent, so don't get in the habit of thinking that. But so tangent of 22 degrees is 0.404. So we'll just round it to 0.4. 100 over x, multiply by x, and multiply that by x. So I get 0.4x equals 100. Divide by 0.4, and I know what x is. So I got to go 100 divided by 0.4, and I get 250. You know things are going well when you get a nice big number like that. So there's 250. Now what I'm going to do is I'm going to take this triangle and think of it as the blue triangle, draw it up here. And so I have, almost looks like a 45, 45, 90 because it's 46, which is very close. This is my 100. I'm going to put a y in there. I'm not going to use x because I already used it for this. I'll make that y. And I'm going to show my math right here. If this is my reference angle, this is my opposite, this is my adjacent. So once again, I'm going to go tangent of 46 degrees equals opposite over adjacent. Sorry about that, got a little feather in my throat. I'm going to look up tangent of 46 degrees. Tangent of 46, 1.03. So 1.03 equals 100 over y, multiplied by y, multiplied by y. So I get 1.03y equals 100. So I got to divide by 1.03, divide by 1.03. So 100 divided by 1.03. 97.08. We'll just call it 97. So if this right here, this little chunk is 97, and this whole chunk is 250, all I got to do is go 250 minus 97. So 250 minus 100 would be 150. 3 less would be 153. All right, so that's how far the car traveled during that period. A little bit challenging then. You have to kind of see what they're asking for right away and then build your strategy to solve it. There is a sneaky little problem on the back that doesn't really have anything to do with angle of elevation or anything, but it said find the smallest angle in a 7, 24, 25 right triangle. So I'm going to try to draw it with a little bit of accuracy. There's my 7, there's my 24, and there's my 25. And if we were in class, we'd have a lot of fun with this. And I would ask you, is this a 30, 60, 90? And I would get some people to say yes. But it's no. Because if it was a 30, 60, 90, and this was 7, this would have to be 14. Remember, the hypotenuse is always double the short side, so it's no. But this is, first of all, asking you to understand, if that's the smallest side, then this must be the angle they're having us find. So student number 1 comes along, and they look at this, and they say, hey, if that's what I want to find, and I'm going to concentrate on these two, then I'm going to say, hey, that's my opposite side, and this is my adjacent side. See, we've been using tangent this whole time. And they'll go tangent of the degree measure we need to find is opposite over adjacent. Student number 2 is figuring the hypotenuse is getting a little lonely, so they want to involve the hypotenuse. So this time, we're going to use this one and this one. Well, that means I've got my opposite and hypotenuse. I tried to make an H there. What trig function in SOHCAHTOA uses opposite and hypotenuse? Sine. So I'd go sine of the angle I'm trying to find is equal to the opposite, which is 7, over the hypotenuse, which is 25. Now, ladies and gentlemen, you have to keep track. What are we trying to find? We're trying to find the angle. So this is where, if we're going to use this one, we're going to have to use our calculator, and we're going to have to go, hey, calculator, do that for me. See, when you engage this button on your calculator, you're telling the calculator, I'm going to give you a decimal, you give me an angle. So that means I need to convert 7 over 24 to a decimal, which is 0.291. I'm gonna be pretty accurate here. So I want to find this. And so how do I do that? Here's where we take a look at our tangent button. Look immediately above it. You see tan to the -1 power. So this is called an inverse function. In other words, you're telling your calculator, hey, calculator, I want to know the angle now. So you're going to go second tangent. You can see what pops up. Type in 0.291, and now it's going to spit out a degree measure, 16.22. So that's what you found. You found theta right here is equal to 16.22. Now let's try it on this one. So this one, I set it up differently, but now I need to find sine, figure out what that decimal is. So I'm going to go 7 divided by 25, and that's 2.28. So I really need to find this. This is a fancy way of saying, hey, calculator, tell me what that degree measure is, because I know the decimal. So you're going to go second sine 0.28, enter. And there it is, 16.26. So what I'm saying is there's more than just one way to do these problems. And I'm not going to finish it for you, but some student could have even went cosine of theta is equal to adjacent over hypotenuse and do the same process and you get the same answer.